So thank you very much, Matt. And it was a great trip. And I will share some details, by the way, of the trip in my presentation. But I think, first of all, I want to thank Open Reality and thank the Echo team and everybody involved in this event, because I think it started from small. And look at the theater where we are right now. It's really an amazing event. And as Matt said, it is getting like a community, right? And a community is like family. And I remember last year, and I feel I have like a little stepson now these days. I'm not sure if he's in the room, but Kieran, are you in the room? Is Kieran not in the room? Oh, the bloody bastard. He should be in the room. But okay, we will find him somewhere. But he's now 1 year in this community. And I think it's also important that we make the community and allow new people in, right? So that's why I will do the part of my presentation, I will start from the beginning. So when Matt asked me what to do about this presentation, at that time, we were working on 802.11r and 802.11k and the impact on modern network infrastructure. So I said to Matt, let me take that part and do some of the research, but I will recap initially what roaming means for those that are maybe a little bit newer into the Wi-Fi technology. So my name is Dobias van Ingen. In HP Aruba, I'm EMEA CTO, and I'm Vice President for the System Engineers. And Troy, man, we better do something on your Aruba certification. If you got 2 Ciscos and 0 Aruba, we need to work on that one. So, having a community, you need to share things, right? And this is, Matt and I were on this trip, and you find some dark sides of it was almost a fetish thing, actually. And then I start to look back, and then I said, damn, we have been sharing many of these things. And it started with this. And it started with this thing where we said, okay, I hate these beds, he said, where you have 2 singles connected to each other. And then we started to send more pictures of each other, of these beds. And then it started to say, I said to him, who came up with this invention? He said, I think it's the Germans. And I said, why? He said, because they always give me this bed. I said, okay, but maybe it's you. But actually, 90% of the beds in German hotels do have like singles attached to each other. But then you can be fooled, right? So I sent this picture. Matt said, oh, now you're telling me that you are in Germany. I said, no. I thought the trend was coming from Germany to Norway, but they only took the blankets, right? The bed was still a king-size bed. But it also works the other way around. I came into a hotel, and this was actually at Mobile World Congress. I came in, and I thought, oh, I had good, but I had to hurry. I had a meeting, and I had to hurry, and then we had a dinner. And then I came back to my hotel, and I wanted to go to bed and think, damn, it's still 2 singles connected to 1. And then you have these extreme German versions. That's this. Who in the world comes up with this, right? 1 blanket, 1 pillow, 2 singles. I said, serious? Is that the thing? And that's why I think I want to do 802.11r and 802.11k in my presentation. So let's start with some of the basic. And why do we roaming, right? Why is roaming? And if you're looking at components, we have an AP, we have a switch, and then we have the rest of the network infrastructure and services we're consuming. But if you think about the network, and I'm not sure where Alan sits, but Alan and I were drinking in Sweden together with Peter, but he was already out of the conversation. But Alan, still the last mile in Wi-Fi is RF to the client. And that's the last mile, and that's the thing, that's what makes it flexible, right? That makes us mobile. But we also need to keep on consideration what the client do. So then, for those that are new to Wi-Fi, for once and for all, it's a client decision, period. That's it. We are not involved, more or less. There is some optimization, but we are not involved. If you don't believe me, start to build a Wi-Fi network without any clients, and I can tell you, it works amazing. Then you have expectations. If you build a client product, you buy a Wi-Fi chip, then you slam it into a product and you're done. But actually, then it starts. The reality is much more complex, right? You need to think about drivers. You need to think about firmware. You need to start thinking, okay, what will be my roaming threshold or my algorithms? You need to start, what is the use case I'm building it for? Maybe a medical device. Maybe it's an IoT device for manufacturing. Then you think about Wi-Fi chip limitations. You need to think about standards. You get out of a sudden, you get a bunch of amendments that you need to do. What about battery life? Right? Battery life, Wi-Fi expertise. You need to fine-tune it. And then, of course, there is budget. Who's going to pay for a certain price for what product? If it's temperature sensor, do you want to have the most fast roaming device in the infrastructure? maybe not, right? So that's why you need to think about. So reality becomes more complex. And there is not a single client that doesn't roam. But as I mentioned, we already discussed, it's a client decision. Roaming thresholds or roaming algorithms are proprietary. It's decided by each vendor that built these devices. Roaming is something that is not defined within the IEEE standard. Right? We have amendments, which we will talk about later, but that's more to optimize it, to make it more efficient, to make it faster, but it's not designed roaming is not defined in the IEEE. So if you're then looking at like what is roughly a logic, that's the way like this. You are connected to a certain AP with a certain signal strength, then it goes down and you get to something what you call a scan threshold. And then the AP starts figuring out, okay, where do I need to go next if I need to roam? And then you go down to the second one, is where you hit the roam threshold and boom, you move over to the next AP. This is what the constant behavior is doing. So how does then this candidate selection criteria works? That depends a little bit. Some vendors are very proprietary about it, so you need to talk to them. Some vendors like Apple, you can find it on the internet, and you have candidate scores on Android, which you can find your information and roughly use that into the design. So when you talk about Android, if you have an Android phone, you can install something called HP Aruba Utilities, and actually you can get some really nice information. It's somebody created by our team. And here you can see that I'm walking in my house, and this is, by the way, a Google 6, which doesn't support 802.11r. I'm connected to channel 36. I'm walking, and C starts to scan, and then out of a sudden, boom, it swaps over, does a four-way handshake, it moves to channel 48. And I'm walking back again. As you can see here, now I'm starting connecting to 48. I'm walking back again. The signal starts to decrease a little bit, and the same magic happens again, and I'm moving back to that channel 36. So if you have this utility and you want to learn and you can verify, or you can use it for design and checks, this is very good, you can do it. So basic roaming, what can go wrong? If it works perfectly, this is how it works. You are connected, and then you have your signal strength. You start to move, the device starts to move, and you get to a point where you get to this threshold where you need to figure out what is my next roaming point. And then it starts to send probes. It gets responses more or less from everybody higher than negative 85 dBm from the APs. Then it makes a decision from this candidate list that can be 802.11k if that's supported, and then it starts to make a decision to roam over. That's perfect world. So, one second, let me go one step back on this one. So this is the perfect world. So then I asked Matt, and I said to Matt, how can I use this and visualize this in my design? And he already showed something in his presentation. He said the inspection tool in AI Pro Online. I said, okay, I want to use that, but I said, how am I going to visualize this? And when I was in Manchester, England was playing the Netherlands at that time. And actually, maybe it was the first time that I was happy we lost, because I don't think, I've never seen more aggressive people than Manchester soccer fans, to be honest. So I was probably happy that I lost. So I said, okay, let me do then an ode to this one. So I'm going to do football coming home again, presentation of roaming inspection tool. So here you go, I put two APs. It's a 735 using expectation tool, and you can see that it starts to move, right? It is connected, starts to move, it gets to certain thresholds, and then it is connected over. But what if I add another AP? So now I add another AP, and it is out of a sudden, it's connected to a different AP by start, meaning that the whole characteristics of the soccer field start to different roam. You can see sticks longer, now it needs to go up, and then it starts to roam. But what if I do 4 APs? I do put an AP in every corner, then I could select all the APs in once, and I could boost up a little bit the transmit power to get full coverage on this one, so that's what I do now. I will boost it up a little bit and start to connect this tool again, and then you will see that the client will hear more or less the APs in every angle direction roughly at the same. So he needs to make a decision. So roaming characteristics completely change. So that's a little bit, I think it's nice to do, visualize it when you are designing. The only thing, Miko, make sure I can customize that tool and that I can tweak all the roaming issues in there so that I can do it for every design and every device in my infrastructure. That will be cool. This is an example of voice over IP handset. And voice over IP, everybody always say negative 65, negative 67 should design. This is a voice over IP handset in real life in one of our customers where it is connected at negative 82. In the driver, you see there negative 62, 66, and 71, and it still doesn't roam. It still sticks, so meaning bad retransmissions, bad user experience, bad voice. Why? I don't know why he didn't do it, but he didn't roam. So then let's look at a recap what can go wrong. TX power, RSSI asymmetry, there is some client decisions, drivers can go wrong, and I want to focus on one thing. RSSI, and I think Connor already always give a great presentation on this one from more from a warehouse antenna perspective, but I will talk about just from an AP perspective without antenna. RSSI is received signal, right? So meaning it's a signal that I hear as from my perspective, from my device perspective. And I'm a little bit deaf actually on one ear. So this is a good example. So meaning I can talk to Mac, and Mac can talk back to me, and then I can it doesn't mean that Mac can hear me, but it doesn't mean that I hear Mac if he talks to the wrong ear, or it's sudden deafness because just Mac started and talk to me, in particular when he drinks. But that's the other thing, but meaning AP RSSI is unequal to the client RSSI, and that is the main thing here. So what is happening, and this is a real scenario which I tried to visualize in this one, is you have an AP or you have a client here, and the client more or less hears everything within negative 10 dBm. So it's selected an AP with a strong power, but it's the furthest away AP. But for him, the green line, the downlink, was good, right? The only way is the AP could not hear him back. What happens is you get retransmissions, you get errors, and the errors become so much that the client goes into certain panic mode. Start the error again and think, okay, I need to start from scratch, and I do it again, and it does the same thing. And then you get into this constant error, which slows down the Wi-Fi for everybody else, and you get the drill. So now let's look at the standards and what we have to support this, right? One summary slide, neighbor report, 802.11k, the AP sends information, and more or less about what he hears around him to support the client to make better decisions, start doing all the scanning. The other one is beacon report. Beacon report is the other way around. The AP asks from the client, what do you hear? And a lot of times what is happening is then the AP is collecting information and then is using V to steer off clients of the network infrastructure. There's a lot of times you do. There's some channel report, and the V is the BSS Transition management, where you more or less can say to the client to move off. And if I always need to compare simple, and I like to keep things simple, is K to me is everything that I can support the client from an infrastructure to make better roaming decisions, to make it more efficient. V to me is where the infrastructure is forcing the client to do something, to move off. So that's always the difference I put in there. Then how can you verify if K is enabled? And I love taking packet captures with the Sidekick too. So here you can see that the radio measurement capability is on. And that actually, I have it running and it's on. Then you can verify in there what capabilities, right? I have here neighbor report on, but you can see link measurement capabilities also, and you can verify what capabilities are supported in this particular one. On the client, you can look at the association request and look at the same thing, right? The ARM capabilities, radio measurement, information element is there, and you can verify the capabilities. Okay? Fast roaming. Fast roaming is to make sure you don't need to do a full authentication, you can skip the .1x part. So it can save a lot of hundreds of milliseconds, but some old devices doesn't support this, and you need to be careful. If you have SSIDs where you have old devices that can't handle this, and I will give some more examples, then you need to be careful when you're designing. So make sure when you design, who are more or less my users or my devices in that infrastructure in order to turn this on, or maybe make different decisions on that one. How can you verify? If that one is enabled, look at here, you have the mobility domain, and in there, actually, you know, the IEEE and the everything else, they are so clear. So look at this one. So you have, more or less on R, you have two things how you can share whatever data, right? You can do over the DS, meaning an AP. You're using the AP as a client to go to the other AP to start roam, more or less, or to start authenticate. In that one, you do also over the air, so you go directly to the other AP. So over the air is not like like very clear how that is enabled. But is over the DS is 0, meaning you do over the air. If over the DS is 1, you do over the DS. So that's a logic where we need to deal with. Okay, so how can you verify this? Look at this. RSN information, you can see the difference between none and one with 11R. So here's the difference. You can see that there is the AKM in there, and you can see that the mobility domain, and it is over the air. And we have so many smart people. What secrets did this RSN reveal more? Man, you're so amazing and so fast, actually. I see the response coming back from all of you. This is WPA and A, so meaning there's also something in there to support non-fast transition clients, right? So you can verify also if that's a possibility instead of only doing 11R. Here you can see the difference between a full out and an FT out. So fast transition authentication, right? Much easier, much faster support. So now, the role of it in modern network, and I like AI, and I asked them, give me a Renaissance picture of Wi-Fi and how amazing this is. And this is what I got. So here we go. What is the impact of K? Let's start positive. We now know what K is. K can really support clients on one side. Where we can even especially see support is there is some clients, in particular clients that are dealing with low latency kind of traffic, that don't want to scan DFS channels because they need to wait and then they can scan. So what you can do with K in this case is we can feed them and they can verify which channels have been scanned, and then they can start probing on it. So we can help them. There is also devices that don't scan more than 8 channels. So with K, we can support them, and you can get less CCI in certain infrastructures if the clients support that. But there's also certain clients, I will get back to that one, in the stationary client, but voice over WLAN completely sometimes change their roaming threshold when K is enabled. So you think you designed something, it all works, then K got enabled, and out of the blue, everything else starts to change, and start to change different decisions. There is clients that don't like the information element of K and say, okay, I'm never going to connect to this SSID. Or doesn't like, for example, the quiet IE in there don't support. So it is really, you need to figure out what support. On the stationary one, you know, Matt is this modern guy, right? Is this hip kind of modern guy, liking his DJ music. So now we have in this certain period where we have all these modern offices with high density APs. And that's where K, in a lot of certain clients, is working very badly because you got high density environment. The stationary clients got all this information via K because more or less every AP sees every other AP, and they start to roam like crazy while they're even sitting stationary. In that situation, turn it off and you stabilize the environment like in a normal way. So it's not always a perfect world. Then what is the impact of 11R? So I also want to know that Hans is here. Hans did a great talk in Prague about some of the wireless design flaws, so I want to thank him for that one. But he talks about that you also need to consider your secondary coverage really, really well in order to think about how your client is roaming. But the clients do some strange things. Some clients do open authentication and then they stitch in an FTR in the RSN information element. And then the AP doesn't know what to do with it, right? And then you have devices that do invalid announce. You have devices that, what you can see here, the R0 from the previous full out is almost like if they're using PMK caching, what they call fast roam back in the past. Or they do like all zeros in the R0 name. So it is like really weird stuff out there. But the interesting thing comes, as a vendor, you are allowed to stick to the standard and say, okay, this is an error. And then you have many clients that go ballistic. If you send them an error, they go to a certain strange state. Some of them immediately stop doing full authentication or doing FTR and go back to normal full out immediately to another AP or to the old AP where they came from. There's clients that say, okay, I'm not going to do something between 5 seconds and 1 minute. I'm not going to do anything anymore. I just wait and then I start up again. And then there is clients that get into this really strange loop where they start doing a full authentication on everything and then they get into a loop and they never authenticate again. So be careful in that one. I have one example for you, and that's my last slide. So a client has the possibility to do PMK caching, OKC, and 802.11r. But what we not always realize is that their cache is not dependent on the roaming algorithm they use. So more or less they have a unified PMK or the unified cache where they can save their keys in, right? So here you can see sometimes we see clients doing if you have an SSID where everything is enabled, you sometimes see clients that more or less try to do everything they can. Like they're going to do a four-way handshake on a .1x AP when you already were authenticated. So you can see really strange things. And then let's give you one example. Here you have a full authentication, and now it starts to do a fast roaming, right? An FT-auth. But it didn't get the proof, but it didn't get the response from the AP. And then it decided, okay, let me start using my PMK cache that you can see here. Let's dive in. You can see it switched to OpenAuth, but it's stitching PMK ID in its RSN information element. Okay, that's weird by default, but then it goes even further. When we are sending the key one message, they said, okay, I'm going to de-auth. So they just don't do anything anymore and stopped, right? So what you can see, I'm not sure why they do it. I think it is like they want to use it as a fallback mechanism, always on working. So that was a little bit of a strange thing. We went back to the vendor and they will probably fix it. So I'm sorry, my conclusion, I don't have a real perfect, so my political correct answer is it depends, and you really need to double check and design. So that's it, so I'm sorry for that one. And actually, Matt, maybe there's more people with our fetish, and maybe we should set up a WhatsApp group, right, on this one, so. Thank you very much.
This one on? Okay. When you started sharing those bed photos, I got a little bit worried you were going to show our private collection. Glad you saved that for just me and you.